In this video, we're going to graph a hyperbola from an equation given in general form. It says convert the following equation for a hyperbola into standard form and graph it below using the transverse axis, center point, vertices, and co-vertices. They give you x squared minus 6x minus 16y squared plus 64y minus 71 equals 0. Notice our x term, our x squared term is positive. That tells us we're going to have this x minus h squared over a squared minus y minus k squared over b squared equal 1. We're going to have that version of this equation. So that's what we're going for here. We're going to add the 71 to start. And we get x squared minus 6x minus 16y squared plus 64y is equal to 71. Let's factor out. Well, we really don't have much to factor out of the first piece. We're going to factor a 1 out just to do something. So we have 1 x squared minus 6x, and then we'd factor a 16 out, or negative 16. So we have negative 16 y squared minus 4y equals 71. Now we're going to complete the square on each of these. So negative 6 divided by 2 squared, and then we have negative 4 divided by 2 squared. Negative 6 divided by 2 is negative 3 squared, it's 9. Negative 4 divided by 2 is negative 2 squared, it's 4. So you end up with 1 x squared minus 6x plus 9 minus 16 y squared minus 4y plus 4. And that's all equal to 71. Now, it's equal to 71, but I have to add in this 9 and this 9 value, which was multiplied times 1, so I better add 9 here. And then also this 4 value that I just added inside the parentheses needs to be taken times negative 16, so that'd be negative 64. So we end up with 1 x minus 3 squared when we factor minus 16. This would be y minus 2 squared when we factor that one. And that's going to equal, let's put a line there, 71 plus 9 minus 64 is 16. So we're going to have x minus 3, I'm going to write it one more time, squared minus 16 y minus 2 squared equals 16. Now we'll divide by 16 on each side. And we get x minus 3 over 16. X minus 3 squared over 16 minus, this would be y minus 2 squared over 1 is equal to 1. Now we can start to find the vertices and the co-vertices. We'll start by finding the center. So the center for this is going to be equal to h comma k, which our center would be positive 3 for h, comma, positive 2 for k. So we have 3 comma 2. Let's check to see if that's right. 1, 2, 3, up 2. Yes, that is the center. Now, we have this orientation. We have the x's first and then the y's. And this tells us that we're, like, imagine we don't know this, that we'd be opening left and right. So what's changing here? Well, what would be changing here is the x values, right? So from the beginning equation, we would know this situation, and we'd know that our vertices, the x values are changing. And our co-vertices, we'd have the y values changing. So for the vertices, we know x values are changing here. So we're going to say h is going to be plus and minus a, comma k. And for the co-vertices, we know the y values are changing here. So we're going to say h, comma, k plus and minus b. So we're just going to add a, which is the distance between the center and the vertex, and we're going to add b, which is the distance between the center and the co-vertices. So we find a squared to be equal to 16, so a is equal to plus and minus 4, and b squared is equal to 1, so b is equal to plus and minus 1. So h, in our case, is 3, so we have 3 plus and minus a, which is 4, comma k, which is 2, and then we have 3 for h here, comma, this would be 2 plus and minus b, which is 1. Let's write those two coordinates. So we'd have 3 plus 4, which is 7, comma 2. And then we'd also have 3 minus 4, which is negative 1, comma 2. And then we'd have 3, comma 2 plus 1 is 3. And then 3, comma 2 minus 1 is 1. Now let's graph all those vertices and co-vertices. So we have 7, 2. Go out here, 7, 2. Yep, that's a vertice. We also have negative 1, 2. Negative 1, 2. That's a vertice. We have 3, 3. So if I go 1, 2, 3, up 1, 2, 3. Yep, that's a co-vertice. And then 3, 1 would be the other co-vertice. So we have it all graphed correctly.